Okay, so we've collected different sources of risk, the failure modes, and the effects of those failure modes. The last one we talked about was the SCORE model, and I just wanted to mention very briefly, SCORE stands for Supply Chain Operations Reference Model, and I'm not going to go into why it's named that, but essentially it is plan, source, make, deliver, return. They've modified it in recent years, but I actually like this older model better. Plan, source, make, deliver, return. And a return is more valid in some industries, not much of a factor in others. So we have a local company that, and now the name has escaped me, that takes cell phones. They insure cell phones, and they plan on cell phones being returned and being refurbished. And so for them, a huge portion of their supply chain is returned. Let's go on to the actual model, failure modes and effects analysis. And at first, what modes and effects are we mitigating, or trying to reduce the risk? So the process function, this is an example that is actually from ASQ, from American Society for Quality, and they had this drilled blind hole, and potential failure modes. The hole could be too deep, or the hole could be not deep enough. And some of the effects, if it's too deep, then you break through the bottom of the plate. That severity is very high. You could not, if you're not deep enough, then when you went to thread the hole for an insert later on, you might not be able to get enough thread, so you had an incomplete thread form, and we call that severity 5. It's on a scale of 1 to 10, and it's a judgment issue. We're not going to deal with class. Sometimes we identify particular, like, sort of hypercritical items in a different class, and we just identify. That's what this column is for. We won't use that. And then the failure causes, or potential causes, of these modes. So improper machine setup could be for the hole too deep or the hole not deep enough, but also broken drill. So I'm having a little bit of a time visualizing that. Perhaps on the first piece, when you break a drill, you leave part of the drill bit in there, and so the hole that's left is shallow. But also, if you keep drilling with a broken drill, then the holes are going to be too shallow. Likelihood of occurrence here, again, these not extremely likely, maybe a little more likely for the broken drill. And then detectability is how likely are you to catch it. In this case, if you're not likely to detect it, you get a higher number. If you are likely to detect it, then you get a lower number. Lower numbers are better. So if I can detect it, I'll catch it before I produce a bunch of bad parts. And you end up multiplying these three, and that's built into the template that I provided for you. And this gives you a risk priority number. Now in your exercise, I'm not going to make you can come up with some proposed actions, but if you'll just go through this first part, I will be satisfied. Now, here we've already talked a little bit about this: severity, occurrence, detection. How do you score? Well, it depends, and different applications are going to have different numbers. So in our case of how will I score the supply chain for different failure modes, well, that's you're going to be somewhat arbitrary. Hopefully you at least have some logic behind it, but I'm not grading very critically there. I just want you to think through the process. And then finally, you end up with a risk priority number. Actually, we had a risk priority number here, but ideally, not everybody does this, but I believe it's good practice to go back and resort this in decreasing risk priority number order. So that's what we did here. And then if you were to complete it, you go ahead and address at least the highest risk issues, and in this case we only had 3 in this little example. I didn't use the example that I built my sticky storms from I didn't use in this. I'll probably show you one, or at least have one if you're interested at a future date. Finally, what are some considerations for you when you create your failure modes and effects analysis for a t-shirt? Well, you could go back to your flow chart and your cause and effect diagram. I do want to challenge you, because a number of you basically were buying the cotton. The Chinese company, Shanghai Knitwear, was buying the cotton from Wrench Farm. That's not actually what happens in real life, and it's not what happens in the book if you read carefully. The Wrench Farm is just one example of many suppliers that supplied. Well, I won't tell you what they supplied, but I think it's at the beginning of chapter 4. Farmers typically will sell their product to a co-op, and then the co-op will deal with customers, because the co-op combines volumes from a whole bunch of different farmers, and it reduces the transaction cost on the part of the customer, and it simplifies the marketing for the farmer. So they're actually buying from a co-op, and the book tells you this. Look at the usual suspects. The usual suspects are cost and time and scope or quality. And you probably have about 2 quality considerations. When I think about a t-shirt, a screen printed t-shirt, what could go wrong? I'll leave that up to you, but a screen printed t-shirt, what could go wrong? And then you should have probably 2 or more delivery failure modes. How could it be late? What along the supply chain is likely to make the t-shirt supply late? And then you could have, I would say, there's actually several cost failure modes, but one is addressed at least to some extent in the book when it talks about the Wrench Farm. It talks about a number of issues, and I would argue that if you look at it on a regional basis or global basis, those cost failure are not going to result in missing cotton, but in fact are going to result in an increased cost as the customer, Shanghai Knitwear, has to go to a different source. So hope this helps. If you have more questions after viewing this, I'll be glad to address them. Thank you. Bye.